Series for a function is given by this. So they give you the general term both right here and in the pattern here. And then they show you the first three terms and the general term. And they ask you to find the first four non-zero terms of the Maclaurin series for f prime, the derivative of f. So before we can do that, let's figure out what the original function is, f of x. And notice they already give us the first three terms. Right here, the first term is x. The second term is negative 2x squared. And the third term is 16 over 3x cubed. But since we want the first four non-zero terms of the derivative, we're going to need one more term here, because this will give us only the first three. And that's where you use the general term, which they show you in two different places, both in the sigma notation right here. There's your general term, as well as they showed here. Sometimes they only show it one or the other place, but here they're showing it to you in two different places. So we can use that to figure it out. So notice the starting number here is 1. So to get the first term, they plugged in 1. The second term, they plugged in 2 for n. The third term, they plugged in 3. So this is going to be the 4 we plug in. So if you plug in 4, we'll get negative 4 to the third, which is negative 64, over 4, and then plug in 4 there, x to the fourth. And now we can take the derivative. To find its first four terms. Oh, and you can write, and then to show that it keeps on going here, plus dot, dot, dot. That's just showing the first four terms. It doesn't ask us for the general term on this one. So when we take the derivative of x, that's 1. Derivative of negative 2x squared, we're using the power rule, that's negative 4x. Derivative of 16x cubed, bring down the 3's cancel out, we get 16x squared. And I left it at 64 over 4. I could reduce that to 16, but notice when you bring down the 4, it cancels out the 4. So you're left with negative 64 x cubed. And again, to show it goes on forever, plus dot, dot, dot. So that's the first thing it asks for, the first four non-zero terms of the derivative. But then it asks something a little different. It says express this derivative, f prime, as a rational function. So remember, rational, a ratio is another word for a fraction, remember? So this is basically saying a fractional function. Well, at first glance, it might be difficult to see how you can express this as a fractional or function, but the key is to look at the pattern. Notice our first term is 1, and then it goes negative 4x, positive 16x squared, negative 64x cubed. So notice to get the next term, we're multiplying by the same common ratio. So that means it's a geometric series. That's the part that they don't tell you you have to recognize. And the common ratio, you notice you're multiplying to get to the next term. It's alternating, notice between positive and negative, so it's going to be negative. And then notice 1 times negative 4x gives you negative 4x. Negative 4x times negative 4x is positive 16x squared, times negative 4x is negative 64x cubed. So the common ratio is negative 4x. And the way we write as a rational function is because, remember, the geometric one is the one type of series we actually have a formula for the sum of all these terms. So remember the sum formula for a geometric series, it's the first term, a sub 1 divided by 1 minus the common ratio. And we know the first term is 1, and the common ratio is negative 4x. So f prime of x, sum of all the terms here. First term would be 1 over 1 minus negative 4x. And notice the negatives cancel out. So as a rational function, f prime of x is 1 over 1 plus 4x. So that's the same as this. It's just because it's geometric, you can express it in a more compact fashion. So now it's a rational function. And then we can use our result from part A to find the value of f prime of 1/2. So now if you do it, substitute in 1/2 there. Whereas if you try to do that in the expanded form as a series, that'd be a lot tougher to figure out what it equals. One over 1 plus 4 times 1/2. Gives you 1 over 4 times 1/2 is 2. So you get 1/3. So that's what f prime of 1/2 equals. And that concludes the notes for AP Calculus on the topic of derivatives of series.